So this first lecture is an introduction to this course, and it will be about some basic aircraft engineering terminology, otherwise known as the ABC of aviation terms, both that are used in the aircraft design and aircraft engineering in general, some of the general notions like the aviation technical complex. We're going to see some classification of the flight principles, otherwise known as the laws of nature that allow us to develop vehicles that are able to cruise in our atmosphere at some very high speeds and very high altitudes. So there are certain laws there that we're going to be exploiting in order to be able to do so. And also, we're going to see some concepts that you're probably familiar with from your school lessons and fundamental disciplines such as physics, theory of mechanics, and strengths of materials. Probably you're going to see this later in your university course. We can start with the concept that is known as the aviation technical complex, where other things that are connected to the aircraft operation that is not the aircraft itself. So we're going to see why it is the case, why an airplane requires other elements to be connected, involved into its operation, which differs the aircraft from other technical means of transportation, like, for example, transport ground vehicles or some other vehicles that do not require any other technical devices for operating them. And finally, we're going to discuss some of the big picture of aircraft operation, denote some distinct stages of its life cycle from initial ideas, research and development, and design of final prototype, mass production, operation, up well into its removal from service, and eventually recycling. So we can start with the aviation complex picture. So this is a rather general picture of aircraft operation, where it can be seen here, unlike other technical devices on the ground again, where vehicles and other means of transportation are able to function virtually independently from anything else. So for example, an automobile, you can just fuel it and it will be ready for operating it, so it will be ready for driving it. An aircraft is a little bit different from that, of course. And as you can see from this picture, it requires a little bit more than just a runway to take off or anything that allows it to take off and land, for instance, like an airport or a runway. So it requires some other elements which are called collectively known as the aviation complex. And this framework goes far beyond the typical things that are required for smaller aircraft. For instance, for example, you need to operate the aircraft. There are some mechanics, there are some airfield, for instance, runway again, and so on. So in fact, it is every system, software, maintenance, management, and personnel working together to ensure both the navigation of the aircraft and the operability of the aircraft, and also the flight safety, right? So the flight safety is the central concept of this complex, and it includes also regulation, by the way. So even some bureaucratic procedures which are required for regulating the aircraft operation are included in this complex. And so here, for instance, we can see a typical day of an airliner, starting with an initial flight planning, which takes into account the weather forecast. So the weather forecast is also somewhat a part of the aviation complex somehow. Air traffic and flight schedules, which is also a management key into the aviation complex. Then flight preparation, taxiing out into a runway, and then taking off, which requires quite a lot of technical devices and so on also to be able to do so. We're going to see this later in the flight principles. The navigation in flight using ground radars and satellites until the aircraft reaches its final destination, performs approach and landing, and then by this point, some ground personnel will be involved into taxiing this air towards a gate. And even by this point, the day of the airliner is far from being over, as the aircraft has to be serviced, refueled, and prepared for its next flight. So you see, the aircraft operation is impossible to imagine without satellites, for example, for navigation, without weather forecast, without the ground personnel that is required for maintaining the aircraft at each and every stage of its flight, both before and after the operation of flight. So that's quite a lot of people, both on the ground and even systems in space, like, for example, navigation satellites that are required to find the aircraft and to locate its location and so on. So that's what we call an aviation technical complex, and it's quite difficult to imagine the aircraft operation without this. So let's give it a proper definition and summarize the idea. So since modern aircraft for proper functioning require technical means of ground systems and software, it should be considered as one element of a more complex system, which is known as the aviation complex. And the aviation complex itself can be defined as a functionally interconnected set of aircraft, technical equipment, management systems controlled by people for performing different tasks, ensuring the functioning of airplanes, which are the basic elements of the whole aviation complex. So this is aircraft is of course a central element of this complex. Now let's see in a very general scheme in this diagram what are the main constituents of this complex. So if we can, for example, classify the complex, we can divide them into the management elements, which is in the center, supplier elements, and information elements. And finally here there is the executive element, which is the aircraft itself. These are the three elements that share information between each other and supply it to the main executive elements, which are the aircraft. And so the aircraft itself, being an element of the aviation complex, is integrated within its framework at certain different levels. And here we can see the levels at which the aircraft can be integrated into the aviation complex here. So the elements of each level are more or less directly involved into the aircraft's operation. So for example, the aircraft functional complex, the aviation complex, the aviation operational complex, the general aeronautical industrial complex. So here we can see quite a lot of organizations that are involved in the aircraft's operation, either directly or indirectly. So for instance, at each and every of these levels, like for example, the lower level here, the design bureaus, the research institutes, the final assembly lines maintenance. So these are the guys that are most directly involved into the aircraft operation. So they design the aircraft. They also provide the aircraft with its maintenance and servicing, right? And some other levels which are more quite more general. For example, that's include, for instance, the storage, the supervision, the equipment, and refueling. So this is quite a rather more general level, where the mine is probably always involved in the aircraft operation from day to day. Now let's see a little deeper into the aircraft itself and analyze it as a system. So the aircraft itself is indeed a system made of various elements. So it includes some various elements which are required for its seamless and safe operation. So these elements work together, perform different functions, and ensure seamless and smooth aircraft operation. So here we have, for instance, the target complex, which is basically why the aircraft is designed. So if it is, for example, a passenger aircraft, then the target complex is the passengers themselves, or the cargo, for example, if it is cargo aircraft, armaments, if it is a military aircraft, research, if it is a flying laboratory of some sort, hardware, equipment, and so on. This is the reason why the aircraft is developed firsthand. So this is this is why it's called the target complex, right? This is called the complex for which we need to design the aircraft. And then we have the lifting complex, which is the metallic part of the aircraft, if you like, that takes the load inside of it. Like for example, the wing, the fuselage, the empennage, the landing gear. So this is the airframe, right? So this is in the aviation we call this the airframe. So this is basically the metallic part, again, that takes all of the loadings of flight in order to ensure the aircraft's flight. And then we have the energetic complex. At its heart, we have a power plant or an engine that is needed, first of all, in order to provide the thrust force, in order to overcome the force of drag, right? And also to provide the energy, to provide every other system with energy it needs for functioning. So here we have some other sub-complexes in this energetic complex. That includes, for example, the fuel, the hydraulic system, the pneumatic system, the electric system. So all of these systems, they are required to both provide the energy, and they themselves require the energy from the power plant, right? So the engine provides the energy to all of these systems, and these systems provide all of the other systems with the functioning required in order to. So every system performs a function that is required to ensure the aircraft's flight operability, right? And finally, we have, in order to control the aircraft's motion in space, we have the flight control system. And that includes also the radio communication system, the radar systems, avionics, which are needed for finding basically the aircraft, locating it, and ensuring ensuring that it's following the right flight path, right? And as you can see here in this diagram, also quite below, we have the aircraft protective systems, which is, as can be seen, it connects everything else. So every system here needs to be protected somehow in order to ensure a fail-safe capability, right? So even if one, for example, system fails, we should not lose the aircraft, right? So and that means that every system needs to be backed up. So there have to be backed up systems. For example, the control system needs to have some other systems which are backing it up, right? So in case, for example, the main control system fails, the other systems should be ready to engage in this case and provide the pilot or control system with the possibility to control the aircraft, right? And that includes here also fire protective systems and some other systems which are also needed for protecting the aircraft from entering potentially hazardous situation. For example, if the pilot performs certain maneuvers that are not safe, so the system should be able to detect these movements and either include some warnings in the cockpit, so telling the pilot that he's doing something wrong, or even engaging into the control of the aircraft and saving the aircraft from entering those hazardous regimes. So all of these is collected in as aircraft protective systems, and they connect everything else together. So they have access to both the engine, the control system, to the control surfaces of the wing, for example, the lifting complex and everything else, right? So it's quite a very general level. Now this slide here is basically summarize everything that has been important, that has been said about the targets, lifting, and energetic and control complex. So again, let's summarize this idea. The targets complex consists of the payload alone with all the systems and equipment required to ensure its proper functioning, life support as well as rescue, right? So life support is also part of the targets complex because it's involving with the passengers' ability, so the ability of the aircraft to provide passengers with comfort and the ability of the aircraft to be a passenger aircraft, right? So, for example, having a passenger cabin, that includes, for example, ensuring the proper temperature, pressure, and so on. So this is called a life support system that is a part of the target complex. Now the lifting complex, which ensures maintaining the payload in the air or on the ground, if the landing gear, for example, is included here. So the landing gear is a part of the lifting system that works on the ground, while the wing, the fuselage, and all of the airframe is part of the lifting complex that works in the air. And the energetic complex provides the aircraft with the energy required for its motion in space, the work of its onboard computer systems, electric and radio equipment, pneumatic and hydraulic systems, and other systems as well. And finally, the control complex, which ensures both an accurate definition of the aircraft position in space, so its location, and its controllable motion along a specific trajectory, right? So these are basically the systems that are included in the aircraft, inside of the aircraft. So if we study the aircraft as a system in itself, so this is basically how to classify everything that is inside of it.